Hello class, welcome to another lesson. Today's learning goal is I can understand and apply the power of a product property, and understand and apply the quotient of a product property, and use properties of exponents to simplify expressions. Okay? We've actually done a whole, actually quite a bit of this already, but we're going to do this in notes and also talk about a different way of looking at these properties. Okay? The first couple of products that we've already learned is the product of powers property and the powers of powers property and the quotient of powers property. A to the m plus n is the same thing as a to the m times a to the n. A to the mn is the same thing as a to the m times n, and a to the m divided by a to the n is a to the m minus n. We've actually been using this a little bit differently, thinking about how different factors cancel as opposed to using the quotient property necessarily to subtract, especially since sometimes we have a bigger exponent in the denominator, and we really haven't talked about negative exponents quite yet, which we will do later on in the week. So, here our first question is 2 times 3 to the third power. And to expand that out, and we know that to be 2 times 3 times 2 times 3 times 2 times 3. If we were to rearrange it with repeated multiplication, it's 2 times 2 times 2 times 3 times 3 times 3. Simplified is 2 to the third times 3 to the third. In this case, when we talk about simplifying, we're not actually trying to find the numeric value. Okay, we're still just trying to write it in exponential notation, which is right here, done for like that. The next one is 5b to the fourth. Which is 5b times 5b times 5b times 5b times 5, and if we reorder it, 5 times 5 times 5 times 5, because remember 5b just means 5 times b times b times b times b times b, 5 to the fourth times b to the fourth. Okay. Here we have 4cd, remember to the second power, which means that 4cd times 4cd. Reorder it is 4 times 4 times c times c times d times d. 4 squared, c squared, d squared. So if we're looking for the pattern, you'll notice that every single factor inside the parentheses is taken to the second power in 4c and d squared. Same thing happens here. 5 and b are taken to the fourth power as well. So the pattern is the exponent is distributed to each factor in the parentheses. Okay. To find a power of a product, we need to raise each individual factor inside of parentheses to that power that's on the outside. And remember, we've talked about this. It might be easier for us if we simplify everything inside the parentheses first before taking every single factor to a specific power. In these cases, nothing had to be simplified, but we have been seeing some questions where you do have to simplify what's inside the parentheses first so that we can get smaller numbers and smaller factors, smaller exponents before taking everything to a specific power that's from the outside parentheses. So, here again, 23 times 17 to the fourth power. Again, we're trying to write this in exponential notation. That is 23 to the fourth power times 17 to the fourth power, because we're taking each factor, 23 is a factor, 17 is a factor, to the fourth power. If we're doing these algebraically, that would be ab to the m. That means that a is a factor, b is a factor. Those things are being multiplied together, which gives us a to the m times b to the m. So go ahead and try some of these examples on your own. Here we have 3 factors, so we're going to take each one to the second power, which gets us 4 squared times 2 squared times 1. Now, this is a very important part of this. This is true, but we can also write it in a different way. You'll notice that 4, if I were to take the prime factorization of 4, it would be 2 and 2. Or if I were to factorize 4, it would be 2 and 2. So that would be 2 and 2 taken to the second power. Okay. And another way we could write it is 2 times 2 to the second power times 2 squared times 1 squared. Here we have two factors taking the second power, so that would be 2 to the second times 2 to the second times 2 to the second times 1 squared. Which also gets us, if we combine these, 2 to the sixth power times 1 squared. And that would be our answer as well. This 1 squared, you can leave it off if you want to, because we know that anything times 1 gets us that thing originally. Okay, so this is not necessary. You can have this or this, and we'll see why this might be beneficial going forward. Here we have three different factors. Okay, ignore this one. I don't want this to be done. Okay, right here, 8 squared, c squared, d squared. Again, we could split this up into 2 to the third. Okay. Squared. So this could also be written as 2 to the sixth, c squared, d squared. Both are perfectly fine. Well, again, we'll see that this might have some advantages for us down the line. Ignore this answer right here. We have -5 to the third power and z to the third power. Okay. Now, when given a question like this, and typically we've simplified this down to this one down here. Okay. We've typically done that. In a question, I will specifically tell you whether or not I want you to simplify the numbers when taken to an exponent. Okay. Typically, that will be the case. Most questions given to you, I will ask you to give us this answer. But for this specific property, right here in these specific examples, and the questions that tell you not to simplify the numeric exponents, okay, numeric bases and exponents, please simply do this. Okay. Again, I will make it very explicit for you so that you will not be confused. Let's take a look at the next one. Okay, this is the power of a quotient. Okay, property 4 over 7 to the fifth is 4 sevenths, 4 sevenths times 4 sevenths times 4 sevenths times 4 sevenths. Okay, again we have 5 factors here, 5 things being multiplied. We get 4 to the fifth, 7 to the fifth. Notice how that is not simplified, but typically I would ask you to do that, but in these specific examples, not right now. A to the third, again, to the fourth power, there's 4 factors of it. 4 factors, 8 to the fourth, 3 to the fourth. Right here, r over s to the third, 3 factors, r to the third, s to the third. And again, the pattern you are seeing is that, not in here, but each element inside, or excuse me, each number, each factor is going to be taken to a specific power. So for example here, r is taken to the third power, s is taken to the third power, s still stays inside the denominator. So each factor is taken to the outside power. Now you might be saying that, well, this s right here is not a factor. S is what's dividing r, not multiplying. Well, remember also that multiplication and division are the same thing. Division is multiplication by the inverse or reciprocal. So remember that r over s is the same thing as r times 1 over s. Okay, that's an s. So therefore, if I were taking r times 1 over s to the third power, this would be taken to the third power, which is 1 over s cubed. And this would be taken to the third power, which would be r cubed. And then you combine those, multiply those together, and bada bing, bada boom, this is what you get. Remember that multiplication and division are the same thing. So, right here, you distribute the exponent to both the numerator and the denominator. Okay, here 2/3 to the fourth is 2 to the fourth over 3 to the fourth. A to the over b is to the m is a to the m over b to the m. So simplify these expressions. Simplify these expressions on your own, and come on back when you are done. Here we get 3 squared, 4 squared, over 4 squared, and r to the 5th over s to the 5th. Okay. Again, try these on your own. Here we're going to have 2 to the 5th to the 3rd power, which is 2 to the 3rd over 5 to the 3rd. 4 times 7 to the 7th is 4 to the 7th times 7 to the 7th. Here again, this is very important that we have the parentheses around the negative 3 because the negative 3 is being multiplied by negative 3. Negative 3 squared times r squared and s squared. Now we're going to take a look at this worksheet. This worksheet is slightly different than the one that you were doing because instead of simplifying, we're going to go backwards. Okay? I know that the directions say simplify. That's not really what we're doing. Okay. What we're doing is trying to find, change this into a single exponent with a single base and a single exponent. So for here, right here, we have 7 to the 3rd times 4 to the 3rd. Okay. Here, what we can do is use the power of a product property and reverse it. So this is very similar to what we have seen. Very similar to this, 2 to the 3rd times 3 to the 3rd. Notice how they have the same power, to the 3rd. And that came from 2 times 3 to the 3rd. So we're going to do going backwards, and try to make this into one power. Okay. One base and one exponent. So this is going to be the same thing as 7 times 4 to the 3rd. Okay. If I were to go from here back to here, we'd be doing 4 to the 3rd, 7 to the 3rd. So these two are the exact same thing. We do not have one singular base yet. So this is, right here, 28 to the 3rd. Okay. Again, these directions are not quite right. I would change this to get a single base to a single power right there. Okay. Those are probably better instructions than what is written right here. Okay. Notice again right here, these two have the same exponent. Okay. So we can rewrite this one as multiplying of the bases 8.3 times 1.2 to the 5th power. 8.3 times 1.2, if you do that inside your calculator, it gets you 9.96. So 9.96 to the 5th power. I'm going to skip number 3. You guys can do number 3 after you do number 4. I think number 4 is a slightly more difficult question, so I'm going to start with that one. Both of these are taken to the 6th power, so we can take their bases. Negative 4 5th times negative 2 thirds to the 6th power. A negative times a negative is a positive. We have 4 and 2, 5 and 3. There's no cross canceling that can happen. So we have 8 15th to the 6th power as our final answer for that one. If we take a look at this one down here, we have a P and W to the 8th. So we can take that and do P times W or PW to the 8th power. We cannot go any further than this at this point because these are variables. We can't simplify them unless we were to know what they were as a number. So this is sufficient when it comes to variables. Okay. Similar thing here. We have to the 2nd power for both of these. So we have 5b times 3c to the 2nd power. We can't simplify the variable part, but we can simplify the number part. 3 times 5 is 15, b, c, all that taken to the 2nd power. So, let's take a look at this one. This is w to the ninth divided by v to the ninth, which we can write as a fraction w over v. Both of them are taken to the ninth, to the ninth. Similarly, over here, number 9, we have both of these taken to the fifth power. So we have 5c over 2b, all to the fifth power. 5 and 2 do not share any common factors. We can't cancel any c's and b's because they're not the same factor. But that's as good as we can get it. Let's take a look at the backside. The backside is a little bit more interesting. We have been doing all questions that are taken to the same power. But what if we have something like this over here? Again, I'm going to tell you right now, each one of these questions, 18 and on, can be taken to the point where we have a single base to a single exponent as numbers. Both of the numbers for base and a number for exponent. So let's take a look at number 18. We have right here 25 to the square times 25 to the 6th. We're going to simplify that and we'll just make it 25 to the 8th power. We have 5 to the 4th times 5, which gets us 5 to the 5th. Now our problem starts right here in the fact that these are not common bases, so we can't use our quotient property. Okay, so in this case, we need to figure out how to change one of these numbers so that we have the same base. Please note that 25 to the 8th power is the same thing as 5 times 5 to the 8th power. We have 5 to the 5th. And if we were to take this even further by using our power of a product property, we would find that this is 5 to the 8th times 5 to the 8th over 5 fifths. I'm distributing that 8 into this parentheses right here, so 5 to the 8th, 5 to the 8th, right here, which gets us 5 to the 16th over 5 to the 5th. And we can simplify that one. 16 up here, 5 down here. We're going to cancel 5 on both the numerator and the denominator, giving us 5 to the 11th over 1. And over 1 doesn't really matter, so I'm not going to write it down. Over here, we have 8 to the 7th, 8 to the 4th, times 2 to the 3rd. We'll start by combining the 8s because we can do that. They have the same base. None of these have the same exponents, so we can't really do much about that. We do have these similar exponents, so we could do something about that. But let's start with the 8. We're going to have 8 to the 11th times 2 to the 3rd over 16 to the 3rd. At this point, we could combine these two right here. Okay. But I think a simpler way than doing that is to take a look at 8 and 16. And we know that 8 is 2 times 2 times 2. So 2 times 2 times 2 to the 11th times 2 to the 3rd over, we know that 16 is 2 to the 4th to the 3rd. Okay. So, therefore, again, we could rewrite this one easily as well. 2b 2 to the 3rd. This makes this 2 to the 33 power times 2 to the 3rd over 2 to the 12th. And this becomes 2 to the 36 over 2 to the 12th. And using a quotient property, we get 36 minus 12, which is 2 to the 24th. At this point, you have all the materials that you need to answer all of these questions. If you have any questions, or if you do poorly on the Edpuzzle questions that are coming up, please come and see me, and we can figure that out.